Hi there, you're right, it's Tommy Allen, and I just wanted to do a quick follow-up video of why we use FEM and a ray tracing hybrid method to calculate impulse responses to kind of get a more accurate sound of what a room might sound like. So in my previous video, I did a calculation of what it would sound like in a giant strawberry, and these are the results. So along here, you can see the ray tracing here in the first graph and the second. So we've got the impulse response here. It looks beautiful. Ignore the picture of me. And then we FFT it and we get the frequency response. As you can see in this graph, we're missing all the low frequency content. So ray tracing isn't very good at doing low frequencies. Also, absorption coefficients start at 125 hertz usually. So it's missing that bassiness to the frequency response and the impulse response. So that's when we bring FEM involved. So this is really, really good for calculating low frequencies. So I did it up to 250 hertz and for the calculation, and then so now we've got a frequency response for the high end and we've got a frequency response for the low end. Okay, so low, high. So now we combine them together with Butterworth filters and with a little crossover, and that's it, crossing over. This is the low, this is the FEM, this is the ray tracing, frequency responses, and now we get a new beautiful frequency response. And this is everything kind of combined. Okay, so they're both models. And then we IFFT it, and then we get a new impulse response that combines them both. So let's hear what that's going to sound like audibly. So I'm just going to bring up Ableton, and I've got two sine sweeps. So a sine sweep goes from 20 to 20,000 hertz. So ooh, we can listen to that now. And that sine sweep, okay, is going to resonate the room, and we can see where the constructive and destructive interference is, and hear how the frequency changes inside the room. So we're comparing the ray tracing alone to the FEM and the ray tracing combined. So what we should see is in one of them we should have absolutely no low end response here, and in the second one we should have let me move myself to the right, we should actually have this extra low end calculated. Okay, so let's throw that through Ableton, and moving myself everywhere. Let's throw that through Ableton, and we should be able to see it in the kind of the audio graph, the spectrograph. I don't know what that's called. Okay, so here we go. Here comes the 4K. Ow. Okay, that might have been a little loud. I'll turn that down in post. So we've run the two sine sweeps with the two different reverbs. We got one hybrid reverb here and the new one on here. And what we actually get, so these graphs, if they were the same impulse response, we should get the same, but we actually don't. So as you can tell, if I just move my little looping bar, especially at the low end, there is quite a big difference. Okay, let's move this over here. Okay, so what we've actually got is, as you can see, we've got a spike here. Here we got a little spike. Then we got a little node, and then the low frequency content actually starts to change quite a lot around here. Okay, so that's actually the FEM model showing us what's actually happening. Okay, and then the rest is the same as expected because it's the same model. But at the low end, there's actually, you can actually visually and hear a slight difference. Let's try and see if we can actually hear it. Actually be too loud. So I'm going to turn this one down to 0. Oh no, to minus 64. Okay, so we won't be able to hear that one. So there wasn't, it sounded quite flat as it moves across. So if we play this one, oh no. Yes, if we play this one, I'm going to put this to minus 12, minus 64. Okay, now we should hear some kind of actual dynamic movement as it sweeps across the frequencies. I can't hear a thing. Oh, that's why. Here we go. So there's a little bit there. I think you might be able to hear. So, okay, so it's quite cool. It's quite cool how it works. Okay, so that's just why we use FEM. This, because the model we actually used was like a giant strawberry, it was huge. So the FEM doesn't make a difference, really. But as soon as we get into small rooms, okay, so this is an example of a big room. As soon as we go to small rooms, the difference is huge. So I'm going to follow up the video and actually show you FEM and ray tracing inside a small room compared to a big room, and we can hear the difference it actually makes. So that's the reason why we use it, and it was just a small little demonstration to show you why. So whoever is watching, I hope you enjoyed it. A little bit of maths. If you want me to go through the code, model something else, let me know. Yeah, and let's meet out.